Hello everyone, let's go ahead and take a look at improper integrals, and remember that what we're trying to determine again is whether an improper integral is going to converge or diverge. Okay, let's first of all get an idea of what an improper integral is. Let's say, for example, we have a definite integral from a to b of f of x d of x. What makes a definite integral improper are two characteristics. One is if you have a domain restriction anywhere within the limits of integration. So let's say, for example, x cannot be equal to c because that is a domain restriction for f of x. If c is anywhere between a and b or equal to a and b, then we're going to consider this integral to be improper. The other situation is when your limits of integration are either positive or negative infinity. If you have any of those two or a combination of them, then what we're going to say is that this definite integral is going to be improper, and what we're going to have to do is we're going to have to use limits in order to evaluate what that definite integral is. So before we actually go ahead and take a look at how to use limits to evaluate an improper integral, let's also go ahead and take a look at the result. Say, for example, if the integral from a to b of f of x d of x is equal to c, where c is an element of the real numbers, then what we say is that the improper integral converges to c. Now, on the other hand, if our improper integral is equal to plus or minus infinity, then we say that the improper integral diverges. So again, notice what we're trying to do is we're trying to establish whether something converges or diverges. Now, let's go ahead and move on to an example. Say, for example, we have the integral from 0 to infinity of 1 over x d of x. I have that graphed here. And of course, what we're trying to do is we're trying to evaluate what the definite integral will give us as a result, which is basically all the area that is contained by the positive y-axis, the positive x-axis, and the curve itself. Now, this integral, of course, is going to be considered improper for two reasons. One is that we have a domain restriction as one of our limits of integration, and we also have infinity as a limit of integration. So what that means then is that both of these conditions are making this particular definite integral improper. Now, how do we go ahead and use limits to evaluate this? What we're going to do is we're going to make sure that only one of our limits of integration is going to make the integral improper. So what I'm going to do is I'm just going to break this up, and I'm arbitrarily going to choose the value of 1. I could choose any other value so long as it exists on the domain of 1 over x. And I'm going to split this improper integral into two improper integrals. And I'm going to say that if I integrate from 0 to 1, and then also integrate from 1 to infinity, I'm still going to come up with the exact same area as if I was to integrate from 0 to infinity, which hopefully makes sense to everyone. Now, the advantage to that, of course, is now what I can do is I can use limits. I can say then that this particular integral here, I can say that this can actually be written as the integral from a to 1 of 1 over x d of x, so long as I make sure that I'm approaching a from the right, as a is approaching 0 from the right. Okay, and that will take care of this particular improper integral. Now, notice that when I take a look at this now, this is actually properly defined because this no longer applies. Okay, and we're actually taking the limit as x approaches 0 from the right. Now, take a look at this one here. If I go ahead and take a look at where the improper limit of integration is, that's the positive infinity. If I was to replace that with b and integrate from 1 to b of 1 over x d of x, notice that this here is actually a properly defined definite integral. But what I need to do is I need to make sure that the limit as b is approaching infinity. So what I can do now is I can just integrate this definite integral normally because it is now well defined, and I just need to include the limit in front. So notice that this becomes that, and if I go ahead and I use my fundamental theorem of calculus, I come up with the limit natural log of 1 minus the natural log of a, which simplifies to the negative natural log of a, and I have to take the limit now as a approaches 0 from the right. Same thing here, I come out with the natural log of b minus the natural log of 1, which is just the natural log of b, and I need to take the limit as b approaches infinity. So what I'm coming out with then is that the limit as a approaches 0 from the right of the negative of the natural log of a, I'm going to come out with infinity, plus I take the natural log of b, and if b approaches infinity, of course, that value is also going to go to infinity. So if I take infinity and plus infinity, of course I'm going to come up with infinity. So we've been able to actually determine what this improper integral is actually going to yield us, and it's yielding us infinity. And the result, of course, is that this integral from 0 to infinity of 1 over x d of x diverges. So what we're going to do then, and let's kind of wrap things up here, is we're going to use improper integrals to be able to help us determine whether or not that particular improper integral will converge or diverge. Again, remember that is the most important part. Now, at the beginning of the chapter, we said that we're going to deal with series. Now, how does series actually involve improper integrals? We'll see that a little bit later. But the most important thing right now that we need to do is be able to evaluate, first of all, identify whether an integral is improper, make sure that we use limits to evaluate, and then make sure that we come up with the proper result. Okay, so we'll take a look at a few more examples and some other theorems regarding improper integrals in a little bit. And I'll see you later. Bye-bye.